Hey everybody, and welcome back to another fun and exciting pre-calculus class. In today's lesson, we'll be jumping into chapter 12.6, the equation of the hyperbola. That is on page number 246 in your book, page 246. Let's go ahead and just jump right into it. Let's not waste any time here. We've got lots of stuff to do. So the equation of the hyperbola, a typical hyperbola is shown in figure 12.0. So this right here, this is the hyperbola. And now you got to look, we're taking this section up here and this section down here. So it's two different parts or two different pieces. And you can kind of follow along right here as I go through this over here on the computer screen. So with the hyperbola, it's two disconnected parabolas. These are called branches. You can see that word in your book. It has two foci and two vertices. They are connected by the transverse axis. And I'll kind of jump back and forth between this so you can kind of look at it here and in your book. But this is kind of like a cross section of it. In other words, here, let's say this is the top one and this is the bottom one, or vice versa. Just rotate that into where it goes. And what you'll see is you'll see that this parabola right here and this parabola right here, their center points, their vertices and their foci are connected with this line, this axis. This is called the transverse axis, and this is like this piece right in between the two vertices. Okay, not necessarily this piece out here. This is just kind of like an extension of the line. We also have this conjugate axis. So this perpendicular to the transverse axis is called the conjugate axis. Notice it's just this piece. It's almost, see this rectangle that they've drawn here? We'll talk about that rectangle in just a second. But this little piece inside of the rectangle is the conjugate axis. And you might say, well, how do I know how long that is, or what? So like I said, we'll talk about that in just a second, but it's gonna, hopefully it makes sense to you once we kind of go through it. And then the other piece here that you need to know are the asymptotes. And the asymptotes are these lines right here. Now these lines, look, the red line, the parabola line, almost touches it but never touches it. That's what asymptote means. So you can see that these are, they end up forming a cross right here. They intersect each other right at the very center of the transverse axis and the conjugate axis. Now, if you draw this box right here, so you draw the length of the vertice between the vertices, and that's your length right here. So we can find the lengths of these two, the conjugate axis and the transverse axis, by, let's come back over here and let's look at it. So down here in this final little section talking about these things, I say that the lengths are equal to the transverse axis, which is 2a. So the length of the transverse axis is going to be 2a. Where do we get the a from? From our standard form in our equation. The conjugate axis is going to be 2b. All right, so that's pretty easy. Just remember that. You can write that down. Transverse axis is 2a. Conjugate axis is 2b. So here's their standard forms. You can look in the book on the next page, 247, and it basically goes through and delineates how they get to that. Not extremely important for you to know all that, but just this is the important part, the fact that they do get to it. All right, so x squared over a squared minus y squared over b squared equals 1. Notice down here they say that the a is always the denominator of the positive fraction. So here our a is the denominator of our x squared because that's positive. This is going to form a horizontal hyperbola. And over here, since this a is with the y, the positive is with the y, then it's going to form a vertical hyperbola. All right, so these are the standard forms, and then we just need to be able to plug into and solve the things with the standard forms. Again, you can go through it all in the book if you want, just like the last few lessons. I think I've got a little bit easier way for you to do that, and that is with all these cool little tricks right here. And yes, it's kind of, a lot of it's in table G, but I want you to write it down, that way you have it. So if we're forming, now this kind of goes with the horizontal, this is the yellow side, and then over here the green side is with the vertical. So make sure that you kind of, as we're going through that, you keep those separate in your notes. So here's our vertices. And so our vertices is going to be plus minus a comma 0. Our vertices over here is going to be 0 plus minus a. Why is it vertices and not vertex? Because we have two. And you might say, it doesn't look like we have two. Yes, we have a positive one and a negative one. Okay. And then the conjugate axis ends are 0 plus minus b, and then plus minus b 0, depending on which one that you're dealing with. All right, then the asymptote is going to be y equals plus minus a over b to the x. And then if it's a vertical, it's going to be y equals plus minus b over a. All that we've done is flip these a over b, and over here is b over a. And then that's to the x, so times x. The foci are going to be plus minus c comma 0, or 0 plus minus c for the vertical one. Now, these ones are the same no matter what. You find the c the same way, you find the lattice rectum length the same way, and then you find the eccentricity the same way, c over a. All right, so let's go ahead and do one. Let's just try it. Doesn't this look like fun? I mean, you guys are having a blast. I know it's really exciting stuff, and some of you are like, I cannot wait to get out of this chapter. I know it's coming. You've only got a couple more lessons, so hang tight, and we'll get through this together. Find the coordinates of the vertices, foci, endpoints, and basically we got to go through the whole thing. So one of the big things that we need is we need our A equals, our B equals, our C equals, and then we'll add to that too. We're going to want to know what our E equals. We're going to want to know what some other things are as we go through this, but for now, let's just do A, B, and C. One of the first things that we have to do is we have to get this into standard form. It's not in standard form. So let's go ahead and divide this by 4, divide this by 4, divide this by 4. All right, so that's going to give us our new standard form, minus x squared over 4 plus, these are going to cancel, we're going to get y squared over 1 equals 1. Now, notice it says that the A is always going to be the positive one. So in other words, this is going to be our A. And so this is not our A. We have to take the square root of that because it's 1 squared. Because if you go back to our standard form up here, we're going to be in this one over here. We're going to be in the vertical. So our A squared. So make sure that you take the square root of that if you want just the A. So the square root of 1 is 1. So we'll write 1 here, and then our b is going to be the square root of 4, or b is going to equal 2 in this case. All right, now technically this b is negative, but let's just use the 2 positive, and then we will apply the negative sign when we need it. For right now, we don't need it, so a is going to be 1, b is going to be 2. How do we find the c? Jump back up here, and there's how to find the C. We've been doing that in the last few lessons, so you should know that one. So we're going to have A plus B, and this is the A squared, so that's going to be 1, plus this is the B squared, so that's going to be 4. So we're going to get the square root of 5. C equals the square root of 5. You can go ahead and figure that out if you want to, and it's going to be approximately 2.2. We may need that in a decimal form as we go through this. So we could do our E right now. Our E is C over A, so we're going to have square root of 5 over 1, or just the square root of 5 here. So basically our C and our E are going to be the same in this one. And now we should have basically everything that we need to solve everything else. So let's go back up here and let's look. Let's start with the vertices. And we're going to be over here on the vertical side because remember our A was with the Y, was with the positive, it was with the Y squared. Very important to know that we're using this column or else you'll get everything wrong if you're using this column. So 0 plus minus A. So we'll write the vertices are going to be 0, comma, plus minus A, and A was 1. So that'll be 1. And you could write those out if you want, like 0, comma 1, 0, comma negative 1. It's fine, or you can write it like this. All right, the next thing that we need is the foci. And the foci points were, going back up here, 0 plus minus C, so we'll do that. and C was 2.2. We'll use that. So it's just easier. So 0 plus minus 2.2. There's the foci. Then we also need the ends of the conjugate axis. So I'm just going to write conj-ax. And that is going to be, and here it is right here, plus minus b0, plus minus b0. And b is 2, so we're going to get plus minus b, so plus minus 2, comma, 0. And then it also says that we need the ends of the lattice rectum. So for that, we'll need to use this one right here. We have 2b squared over a. So right here, 2b squared over a. So 2, and then b is 2 squared over a. So that's a squared. There we go. So that's 4/8 over 1, or just 8. Now notice that this gives us actually our lattice rectum length as 8. Okay, now let's go back up here to the question and ask what see what they're wanting. They don't want the length. They want, and I didn't really write it out here. I should have written it out here. But in your book, they want the lattice rectum ends. They want the ends of that. So they want points. Well, how are we going to do that? Well, let's jump back over here to the book and let me show you something. Let's go back here to page 247. Right down here at the bottom, it says, therefore, the endpoints of one lattice rectum are c b squared over a and c negative b squared over a. And because we have 2, we need to use the plural. The plural is latera recta, which is on page number 249 right here. So latera recta, just whatever, lattice rectums. That's kind of a weird way to say it, but you know what I mean. It's the plural. So go over here. Don't laugh at that, okay? I know you're not supposed to be laughing. But anyways, we'll go back over here and we'll find those by using this little formula right here. You'll need to write this down. So let's go back over here and write this down. So again, we want the lattice rectum endpoints. Okay, there's going to be 4 of these because we have each endpoint and then we have it 2 different lattice rectums. So let's do this. Let's go ahead and using this and using what's in your book, let's write these down. So for the first one, you'd have c comma plus minus b squared, and we would need to put that in parentheses so that the plus minus would still apply to the answer, over a. So that's one of them. And then your other one would be minus c with the same thing, plus minus b squared in parentheses over a. Those would be your 4 points for your lattice rectum. All right, now this here, this would be for the horizontal. So we would also need to come over here and do the same thing with our vertical. I'm not going to take the time to rewrite that, but basically we're just going to, for the vertical, we're just going to swap those points. C is going to go to the other side, and the B over A is going to go over to the other side. So we're just going to swap those. Let's go ahead and solve for these things. So over here, we're going to have our plus minus B squared. What was B? It was 2. So 2 squared is 4 over A. So that's just going to be 4, comma C. C was our 2.2. So there's one side. There's one set. And then the other one would be the same thing, the plus minus 4, comma negative 2.2. Now, how do I graph this? I'm not going to take the time to graph it. We will look in the book how they graphed it. But let's just kind of talk through this. How do I graph this? Well, graph it piece by piece. Graph your vertices, then graph your foci, then graph your conjugate axis. Then you could graph your latera recta here. And then let's skip back over here to the book real quick, and then let's kind of talk about kind of the ending of how we're going to do this. So we're going to plot all these points, and then we're going to draw, we're going to extend those diagonals. Basically, we're going to take the corners of those rectangles that we ended up making right there. right here, and we're going to take these diagonals, and that is the diagonals of this rectangle on the inside here that we formed with all these points is going to be our asymptotes. And that should be it. You should be able to put all those points on there. You should be able to get your foci, your vertices. You should be able to wrap your... Now, I would put everything before. The last thing I would do is basically the parabola, because everything else is going to go on it, and then that's going to tell you where your parabola goes. So you can't really put your parabola on till you get your asymptotes, till you get your rectangle, till you get your vertices and your foci. Just get everything on there, and then last but not least, you would graph your parabola in there. All right. Now, what happens if we have a movement? Same thing we've been doing. The h and the k are going to move it left or right, and so you're just going to translate it. What I would do is I would do the translated origin. So in other words, I would take my translation, I would move it to where it needs to go, lock that in. That becomes my new 0, 0 point, and that will just be easier doing the translated origin first rather than trying to translate every single point. You could, but it gets really complicated really fast. Another thing real quick here in example number 2, what if they give you this equation right here and they say graph that? Well, we need to put it in standard form. This is not that hard. We've been doing this. Complete the squares. Once you complete the squares, you're going to make sure that you get this equal to 1, and that's going to give you your standard equation. Now look on this one, we have movement. So we have a -2, which actually would be a +2 when we move that on the x, and this would be a -1 on the y, and so you would move and rotate your graph based on those points. Here's your h and your k. Move your graph, recenter your origin on that new point, and then do all the rest of your steps. Get your foci, get your vertices, get all that good stuff, and then draw your graph. Plot your points, put your parabolas on there, and all that good stuff. Make sure you don't forget your asymptotes. Your asymptotes are really what's going to allow you to be able to draw your parabola. Because once you get your asymptotes on there, then you can just say, okay, it bends right here, here's the vertex, and it can't touch either one of these lines. And so you just kind of know where it has to go once you get this X marks the spot right here. All right, one more thing, the last thing is, so what if they just give you some points, some translated origins, the eccentricity? You're just going to work your way backwards. All right, so we know what eccentricity is. It is c over a. The difference from any point on the hyperbola to each focus is 8. So we know that we would basically cut that in half and do different things. So if they give you that, you're just going to work backwards from the information that you know. All right, and that's really all I have for you in this lesson. There's a lot of stuff there again, but a lot of it's just kind of repeating what we've already done. Is it complicated? Yes, but at the same time, is it simple? Yes, because you're just breaking down each piece by piece, and then it's not as challenging. Yes, the overall problem is challenging, but please look at it like, okay, I've got all these little mini problems in here, so learn how to do the mini problems, write those formulas down, and then I think that it should be a lot easier for you than looking at the overall, oh my goodness, this is so much work, and it is. But break it down piece by piece, take your time, and you should be able to handle this. Go ahead and make sure that you're practicing on those, because you're going to see those again on quizzes and tests. All right, that's all I've got for you. Hope you learned something. If you missed anything, slide it back, watch it again. We'll see you later. You have a good one. Bye-bye.